Okay, good morning, guys. Today, what I'm going to do is I'm going to quickly walk you through the four problems on the note sheet for the 2.1, 2.2 review. So, if you have any questions about those, make sure you're listening and taking notes. And then you can work on the 10 required homework problems. And then on Monday, we'll have the quiz on 2.1, 2.2. So, let's go ahead and get started with the first one. It's asking us to take this function f of x equals 2x squared minus 12x plus 16 and find the vertex and write it in vertex form. So I like to start by getting it in vertex form and then using it to find the vertex. So to get this in vertex form, we have to complete the square. So I'm going to group off the first two terms, and then what I'm noticing is that I have a leading coefficient of positive 2, so I need to factor that out and leave a blank for the term that I am going to use to complete the square. And whatever I add here, I have to add the opposite of here to make sure that my equation is balanced. So remember, to complete the square, you take your b term, which we have negative 6, and cut it in half, and then square it. So negative 6 divided by 2 is negative 3. Squared is positive 9. So I'm going to add positive 9 here. But I didn't actually just add positive 9. I added 2 times positive 9, which is plus 18. So that means at the end of my equation, I'm going to add negative 18 to balance it. So what this has allowed me to do is create a perfect square trinomial, which can now be factored. Factors of 9 that add up to negative 6 are negative 3 and negative 3. 16 plus negative 18 is negative 2. And now I can just write this as 2 times negative 3 squared minus 2. So here I have vertex form. And then the second part of the question is find the vertex. So the vertex is the opposite of this value, so positive 3, and this value, negative 2. That's your horizontal shift and your vertical shift. So the vertex is 3, negative 2. Okay. Part B wants us to use the same function. So I am going to write the vertex form, because for some of these questions we're going to use the vertex form. For some of these questions we're going to change it up a little bit. So part 1 says find the x-intercepts. Well, the best way to do that is to find when the equation equals 0. Okay, well, to do that, I'm going to factor it and get it in intercept form. So before I factor it, I notice all three terms are divisible by 2, so I'm pulling out a 2. And now I'm just going to factor the remaining quadratics. So what factors of 8 add up to negative 6, negative 4, and negative 2? So that makes the zeros, or the x-intercepts, 4 and 2. Okay. The y-intercept actually occurs when you put 0 in for x. So 2 times 0 squared minus 12 times 0 plus 16. We get 0 minus 0 plus 16, which is 16. So the y-intercept is 0, 16. Okay. Axis of symmetry formula is, well, either the axis of symmetry goes right through the x-coordinate of the vertex, so x equals 3, or you can find that by taking the opposite of b over 2a. So the opposite of b would be 12 over 2 times 2. That's 12 over 4, which is 3. So you can do it either way. I'm going to jump down to the sketch and sketch this before I answer any of the other questions, because the sketch is what's going to help me. So in my sketch, I have a vertex at 3, negative 2. I have x-intercepts at 2 and 4. And because my leading coefficient is 2, that means this thing opens up. So since it opens up, it's got a minimum. And the minimum value is the y-coordinate of the vertex, so -2. My domain goes from -infinity to +infinity. My range goes down to -2 and up to +infinity. And there we have everything related to this function. Okay. In C, they've given us the function in factored form already, which is nice. So, in order to find degree and leading coefficient, I am going to multiply all the leading terms together. So we have 2x, x, and x squared. So 2x times x squared is 2x to the 4th. So that makes the degree 4, which is even. And that makes the leading coefficient +2. So that means my graph is going to look something like this. So for the end behavior, I can say that as scratch that, x approaches +infinity, meaning as we go to the right, f of x is going to also approach +infinity because the graph is going to go up. I can also say that as x approaches -infinity, as we go to the left, f of x is also going to go up, so approach +infinity. Okay? Now, in order to make the sketch, I'm going to want to get the zeros and be able to tell if they are touch points or cross points. So, for the factor 2x minus 7, the 0 would be 7/2. And since there's only one of them, it's odd, making it a cross point. For x plus 3, the 0 would be -3. And since there's only one of them, it's odd, making it a cross point. And for x minus 1 squared, the 0 would be 1. But there's two of them because it's squared, so it's even, making it a bounce point. So to sketch this, I'm going to start by drawing my zeros. 7/2 is like 3.5, -3, and 1. And I have my sketch up here that I'm going to use to help me. Since I know it has to come from up here, -3 is a cross point. +1 is a bounce point. And we've got to cross through 7/2 to end going upward. So there's a nice sketch right there. Okay. And our last question, we want to do the same thing, identify the leading coefficient and behavior and sketch it. So first I am going to multiply together all my leading terms. Well, in order to do that, I have an x squared times an x times an x. Actually, this was an x cubed. And times a -x. So I get -1x to the 5, 6, 7. Here the negative in front of the x is what actually makes our leading coefficient -1. And our degree, even though it's not listed here, is odd. It's 7. So that tells me my graph is going to look something like this. Ends are going to go different ways and it's going to have a negative trend. So, what does that mean for my end behavior? As x goes to the right or approaches +infinity, f of x is going down, so approaching -infinity. And as f of x goes to the left, approaches -infinity, f of x, the graph is going up to positive infinity. Okay? And now we need to sketch. So I'm going to identify my zeros and whether or not they are touch or cross points. So here for x squared, x would equal 0. And since it's squared, it's going to have an even multiplicity, which means that it is going to be a bounce point. Here x would equal 2, and since it's raised to the third power, it's odd multiplicity, so that means it's going to be a cross point. Here x is negative 3, and since there's only one of them, that makes it odd, so cross point. And here x would be 4. And again, there's only one of them, so it's odd, making it a cross point. Okay, so to make my sketch, I'm going to start by plotting the zeros. 0, 2, negative 3, and 4. And now according to my sketch down here, I need to start from up here. Negative 3 is a cross point. 0 is a bounce point. 2 is a cross point, and 4 is a cross point. We need to end down there. So it's a little bit rough, but it's a pretty good sketch. I've got all my zeros and whether or not they're touch or cross points. Okay? Perfect. All right, that's it for the 4 examples for today. You guys have the 10 problem homework assignment at the bottom of your notes sheet and right here. So make sure you absolutely get those 10 problems done for Monday. And then on Monday, we'll check the 2.7 variation assignment. We'll check this assignment, do our review quiz from 2.1, 2.2, and then do the notes on 2.3, 2.4. All right? I hope you guys all have a great weekend, and we'll see you on Monday.